Hello, I'm Jonathan, and today we will be exploring different ways to exploit L'Hopital's rule in order to better solve different kinds of limits. Our first method will be exploiting the log natural. If we take the limit of x to the x squared as x approaches 0 from the right, we can simplify this by taking the log natural of x to the x squared, which, by log rules, we can, of course, simplify to x squared times ln x. If we take the limit of this, or the limit of x squared times ln x, as x approaches 0 from the right, we get an indeterminate. Now, here we can apply L'Hopital's rule in order to get the limit as x approaches 0 from the right of 1 over x divided by minus 2 over x cubed, which, if we plug in 0, we can see equals 0. Now, because we took the log natural of x to the x squared in the very beginning of the problem, we need to take the inverse operation in order to find our real answer. In this case, since our limit of our log natural was 0, we take e to the 0th power, which is equal to 1. So therefore, that is our answer. Some very common errors with this is, number 1, forgetting to take the inverse operation at the end of the problem. This is an extremely common error, in that one can oftentimes solve for the limit as x approaches a certain number of the log natural of a certain expression instead of the expression itself. So one should always remember to take the inverse operation as soon as you're finished with finding the limit of the log natural. The second common error is to mindlessly plug 0 from the right into the initial limit. In this case, we would get an answer of 0 if we had applied it as such. Finally, another common error would be breaking down x to the x squared into further multiples, or, for example, simplifying x to the x squared to x to the x squared minus 1 times x, and attempting to find the limit of that expression through a variety of other mechanisms. Another method of exploiting L'Hopital's rule in order to better solve limits is through basic trig manipulation. Take the limit as x approaches 0 of the cotangent of x minus 1 over x. This can be simplified to cosine x over sine x minus 1 over x, which in turn can be simplified to x times cosine x minus sine x all over x times sine over x, which is indeterminate. So, in our first round of L'Hopital's rule, we find that our limit is now equal to, when simplified, the limit as x approaches 0 of x times sine x all over x times cosine x plus sine x, which is also indeterminate. So therefore, we take L'Hopital's rule again, and in the final round, we get the answer of the limit as x approaches 0 of x times cosine x plus sine x all over x times minus sine x plus cosine x, which is equal to 0 over 2, which of course is equal to 0. Some common errors here. Mindlessly plugging 0 into the original limit. Now notice that if we utilize the definition of the limit as x approaches to 0 by plugging in smaller and smaller positive points into the limit, which is essentially taking the limit of 0 from the right, we will get the same answer as our correct answer, which is 0. However, the process for this is not correct and therefore will not be graded with full points. Well, when it comes to multiple rounds of L'Hopital's rule, it can oftentimes get confusing as to what you're taking the derivative of. The derivative of. So it should be essential to keep the derivative of the top and the bottom separate, because as you should know, L'Hopital's rule is defined as f prime over x over g prime of x. In this sense, the f of x is the expression on the top and g of x is the expression on the bottom. Our final example is essentially both of the previous methods put together into a singular problem. Take the limit as x approaches 0 from the right of 4x plus 1 all to the power of cotangent of x. So, similar to example 1, we take the log natural of 4x plus 1 to the cotangent of x, which in turn yields us the limit as x approaches 0 from the right of the log natural of 4x plus 1 to the power of cotangent x, which in turn can be simplified by log rules to the limit as x approaches 0 from the right of cotangent x times ln 4x plus 1, which is indeterminate. So when we first use the first round of L'Hopital's rule, Notice that we simplified cotangent x to 1 over tan x for simplification. We will get the answer of the limit as x approaches 0 from the right of 4 over 4x plus 1 all over secant squared x. This in turn is equal to the limit as x approaches 0 from the right of 4 over 4x plus 1 times secant squared x, which is equal to 4. Now, because we took the natural log of 4x plus 1 to the cotangent x in the very beginning, we have to take the inverse operation, as similar to problem 1. This is e to the 4th power, which is e to the 4th power, and therefore the limit as x approaches 0 from the right of 4x plus 1 to the cotangent x is equal to e to the 4th. Now, some common errors. This is essentially a combination of the previous errors of the previous two problems, and that the first and most important and most common mistake is to forgetting to take the inverse operation, and that to put e to your answer of the limit of the natural log. Or, essentially, as before, just simply taking the inverse operation as you took the log natural of the initial problem in order to solve the problem. Again, mindlessly plugging in a 0 from the right to the original limit will yield an answer of 1, which is obviously incorrect. That is all, I think. Bleh.